All right, so this will be a tutorial on our lab assignment. Let me go ahead and share my screen. And you guys should definitely see the lab again. And this is the Python notebook that we will be using to assess the properties of our CCD chip within our camera. And it'll be based off of the frames that we took during lab 1 and during the lab 2. Lab 1, we took some flat fields that were set to a specific exposure time. So that way we could collect approximately 30,000 photons or counts from our source. And we wanted that to be an even flat distribution across the chip. And we're going to kind of see that today. We'll also go through and essentially calculate some kind of relative quantum efficiency. And it's just some fancy word to tell you how many good pixels you have and how many pixels you have that aren't very good. And it gives you somewhat of a sense of how good our equipment is or how good it is not. So I won't spend a whole lot of time on this very first cell. I could have a whole nother video talking about each one of these different packages individually, except maybe glob. Only because this one and this one are the most important ones that we have. They are doing most of the work for us, especially this with the ability to manipulate FITS files. And this will be doing the math for us on the data from those FITS files. So when we go through here, actually, before I continue, the proper name for these are called packages. And Python uses these to, people have made these to make Python more of a convenience to use. More specifically, this NumPy increases the speed at which Python can do mathematical manipulations on lists of data. So one might ask, oh, what's a list? We will get to this. So the first thing that I want to do is let's go ahead and just execute that. In fact, let me just start from complete scratch. All right, so I'm going to run this. And to run this cell, all you have to do is press Shift and Enter at the same time, and it'll continue on to the next one. And you can do this for these cells here as well, and it doesn't run any code, it just skips to the next cell. So in this cell, you might want to go ahead and put this line of code into your code as well. The reason why is it's used, I have found a way to use it differently with the help of a fellow classmate that is in your class. So if you take a look at this, this particular code has some comments in it. Yours might not. In fact, this is a good place to start. It's often good practice to leave yourself comments when you're coding. These comments usually say what the next bit of text means. So in this case, there's some tips here, and it also tells me how I should name things. Because this is being recorded, you guys will have access to this and you'll see these comments and you're free to add them in. They do absolutely nothing to the code. In fact, this hashtag in front of each of these is what causes it to be a comment. If I delete this hashtag, notice that line becomes black. It looks like regular text. And so if I add the hashtag back in, we get this greenish bluish color. And that means that it's commented out. And so what will happen is when I run this cell, Python will get to this line and it'll say, okay, I need to import this package RE, and it'll do so. And then it'll move on and it'll see that this is a blank line, so it'll skip it. It'll see this hashtag and it'll think that it's a blank line and it'll skip it. And then same thing here, it'll skip this, and it'll skip this line, and then it's going to come to this line. It's not going to skip this line because there's no hashtag. So what this means is when Python looks at this, you're going to see, or it's going to see this first. And then it's going to get to this point and it's going to say, okay, everything right here is a variable. And because it's a variable, Python can store all kinds of information in it. It's just like a variable that you would use in math, except the information that we're putting inside of the variables in math are just numbers or functions. So in this case, a variable is just, it's like an empty box until you decide to put something in it. Which brings me to my next point. Once Python looks at this variable, it's going to say, okay, what comes afterwards? And so it's going to get to this point. And for this portion of the code, Python's going to look at this and it's going to say, okay, here's some special command from glob. I imported glob, so I got to go to the inside this package and essentially grab whatever I'm being asked to grab. And in this case, glob is grabbing glob. Okay. It's kind of redundant, but the glob package is special. Its specialty is collecting files. And so essentially when you glob something, you are collecting an assortment of files. So inside of this, there's this, oh, I don't want that to change anything. There's this thing. There's this text, and it's red. And it starts off with an R. It's got some, why can I not remember the name of these quotations? And it has this text in the middle. Now, the text in the middle is going to be different whether you're a Mac user or an Apple user or a Windows user. If you're a Mac user, I believe that you don't need this part. And I also think that instead of having your slashes in this direction, they need to be in this direction. I will walk through a little bit more on how to collect your path, but let me get through this cell first. So in my current line, when Python gets to it, it's going to see that there's this variable file name list flat imp. I named it this because it's for image processing, and it tells me that what I'm going to put in here are the files from the lab where we took the calibration frames for image processing, which was lab 1. We took 10 flat fields, 10 dark frames, 10 biases. So this red text is where I put in my file path to where the data is at. You'll notice too, I didn't say anything about this, but there's this extra bit of code outside that kind of borders what we were just talking about, and it's called sorted. And what that does is it kind of just makes sure that everything is in a proper order. So maybe in your directory, for some reason, instead of it saying flat frame 001, 002, 003, maybe it says flat frame 060, 005, 010, 400. And maybe it's all jumbled up like that. But file name, or when you put the sorted around it, it will grab it and organize it for you in the most alphanumerically efficient way. So it won't organize it in your directory, but it will organize it in this variable that is in the code. All right, so I've said a whole bunch of words. I want to give a minute to for you guys to ask any questions about variables or packages. Okay. So the next thing that I want to touch on before I get down to this part is with Jupyter notebooks, you see here that these texts, these different parts throughout the code have different colors. And what that is it's called a GUI. It's called a user interface. And it's part of the real-time checking system that Python comes equipped with. One of the reasons why so many people use this language is because there's so much self-check that goes on before you execute the code. With older languages like Fortran and C, you just write the code and hopefully when you press the play button, it works. Otherwise, you have to read the errors and then go back and reformulate the whole code again, and then you keep repeating the process. Just to show you the beauty behind what I'm talking about, I'm in a cell that we talked about earlier, but I'm just going to delete something so I can cause an error. And so when I do this, we see that Python is very responsive. It tells us exactly what's going on. It says that there's an invalid syntax and it's going on somewhere in line 1 of this cell. And it's telling me that it's located after as in that line. So if I go to line 1, which is this line, I'll see that, okay, here's as. There's nothing after it. Now, because I know what I'm doing, I find it a little hard to explain what I'm about to say, but I can choose to delete this and it'll work, as you can see, or I can add this back in, okay? And it'll still work. Now, I don't want to go into, for the purposes of this video, I don't want to go into why I have done this like this. I just really want to explain the bare basics of code and the basic terminology that we use. So far we've discussed packages and variables, and the next things that I want to address are the green and the red. The green is, in this case, it's a function, but what it is it's something that Python is pre-built with. So this is sorted. So Python is pre-built with that. This from command is green. It's Python is pre-built with that. Import is green. It's pre-built with that. So these things, when you see the text as being green, that's stuff that Python recognizes as a command of some sort. So when we get a little further down into this portion, I'll talk more about commands and how Python uses them. So the green is a command and red stands for strings. A string is it's a configuration of letters and numbers to make a real sentence appear in the code. If I chose to print this, it, I believe, should immediately just print in the output. It'll print what we see here, the C colon backslash users, all this. And that's exactly what happens. So it prints what's inside the quotation marks. So what that means is that Python reads what's inside the quotation marks. So when Python reads this string, it knows to put whatever's in that string. In this particular case, we're grabbing files. It knows to put that file inside this variable. So I'm going to continue a little bit, and then I'll ask about questions again. The next set of things that I want to talk about here is this portion. We have image data flat ccd sat, and then we have image data flat imp. Both of these variables you see have these empty brackets around them. Okay. The empty brackets indicate to Python that this is an array or a list. Python by itself, with no extra packages, refers to these as lists. And a list is just a collection of different data. So if I wanted to, I could put in here some numbers, 0, 1, 2, 3. I could also put in a string like Python Pow Wow, astronomy rules. Let's see how many other lame stereotypical things I can come up with. Hi world. And all right, this works. For the purposes of this next demonstration, I have filled this list. So I'm going to comment out the portion of the code that fills that list. So that way it doesn't make things worse for me. So what I'm going to do is, for the intention of demonstrating this, I'm going to go ahead and run the cell, and you see that everything works. So now what I'm going to do is I'm going to print image data flat ccd sat. And what it's going to do is it's going to display all of these things inside there. And it displays them exactly as I wrote them in. Now, due to the nature of lists and how Python uses them, I can go in and I can call any individual or set of things that are inside the list. So maybe I want to grab the number 3 and astronomy rules. Maybe that's what I want to do. So what I'm going to do, and I'm going to go ahead and just write this out and then explain it. All right, so if you notice here, I'm going to highlight the line. I have image data flat ccd sat, and that's a list. And I have these brackets with the number 3. Now, it's very coincidental that this 3 is the same as this 3. But what this means is that when I go to this brackets and I put a number in here, it's the position. What it's going to do is Python is going to go and grab whatever's in image data flat ccd sat in position 3. Now, Python starts at position 0. So if I were to type a 0 in here and print this, it's going to print 0. Let me just do this for demonstration. And so the same thing here. I've got 2 of these inside this print statement. Python will print both of these. And so I'm going to hit enter. And then if we take a look down here, what I've done is I've asked Python to print the initial value inside, or the beginning value, or the first value of the list image data flat ccd sat. This next command or portion of the command tells Python to grab whatever's in the 3rd position. And so without looking at the answer here, we can see that the object or whatever data value is in the initial position or the first position is 0. And so it should print 0, and it did. The 3rd position is 3. So when I print it, it should print whatever's in position 3, which happens to be 3. And just for a demo, I'm going to type 5 here, and I'm going to type 7 here. And you can leave it in the chat But what do you think it's going to print when I hit enter? And you like if you want, you can say it or you can leave it in the chat.
5 will spit out 0, 1, 2, 3, 4 astronomy rules, and I have no idea what it would put out for 7 because there isn't a 7th spot.
Very good. So it shouldn't print anything. It should probably give me an error, right? Let's see what happens. I'm going to hit. Oh, I did. And it should tell me that my error is exactly where we said it was going to be. So it says that the error is here and it says that it's out of range. There's not this many elements in this list. There are only 7 elements. 0, 1, 2, 3, 4, 5, 6. This implies that there are 8 elements. Does that make sense?
Yeah.
If it doesn't, that's okay. So if I change this to a 6, we get astronomy rules and high world, which is exactly what we would expect. So let me explain real quick why we get this error when I type 7 in. So because Python starts counting items as 0, with 0 being the first number, that means the quantity is always going to be 1 more than the position. So in that case, since we're counting from 0, 7 is technically the 8th number, 5 is technically the 6th number, and 4 is technically the 5th number. Because if you count it on your hand, you go 0, 1, 2, 3, 4. That's the 5th number. 5, 6, and that's 7. So if we look here, we have 6. And so therefore our maximum number should be 7. I'm sorry. Our number of items in our list is 7. So therefore the maximum number that we can call on is 6. Okay. So if you're following along and you're watching this through video, you don't necessarily have to type all these extra things that I'm typing in. I'm just doing this for demonstration. And so the next thing that I want to do is finish what I'm saying by saying that we have another variable here that is an empty list. And so I'm going to go ahead and delete everything in this list to put it back to normal. Then I open the floor to questions if you have any. Okay. So we've gone over packages, variables, strings, functions, or pre-programmed commands, and we've gone over lists and arrays. I've shown you how to access individual elements using the print command. If you can print it, you can do anything you want with it, because if you're able to print, you should be able to do math manipulations as well, if the file or variable type calls for it. We haven't talked too much about variable types yet. And we probably won't get too terribly far until that becomes an issue later. So the next thing that I want to go over before we get, actually, this will probably be the last bit that we'll need. And I'll probably explain some more plotting stuff. And then we'll continue on with actually the assignment. So the next thing I want to talk about here is these two things, these two objects inside the code. And what they are, they're called for loops. And what a for loop does is it says for something inside of this list of somethings, we want to do these operations inside. In Python, the way that we do for loops is once you type in for, you see that it's green. So Python recognizes this as some kind of special command. The next thing is some dummy variable. We get to choose this to be whatever we want. Now, it's good practice to make this dummy variable something that provides information. I chose this to be file name because that's what we're trying to access. We're trying to access file names from a list of file names is what this means. So if you see here, it says file name, and then it says file name list. So this is a variable that's a list of file names, and this is a dummy variable that we're going to use to kind of sift through those different things inside the list. So when Python reads this, it knows, okay, as long as we have some file name that's in here, I'm going to keep running through this until I get to a file name that's not in there. And that file name might be nothing. And once it gets to nothing, it'll be like, oh, okay, I'm done. So one other thing that I should touch on is for loops in Python, once you write out this top line, to really tell Python where the for loop begins, you put this colon. And if you notice, if I go to the right side of the colon and I press enter, I don't start over here like we have been, or like you normally would. What happens is Python is smart. When you put this colon here and it sees this for and this in, Python knows that you're making a for loop. And so it's going to keep you inside the for loop. So this indent, this one indent, means that we are inside this for loop. Now, for demonstration purposes, if I wanted to, I could, if I delete an indent, so what I'm going to do here is I'm going to print a statement outside of the for loop, and then I'm going to print that same statement inside the for loop, just to demonstrate how Python reads for loops. So if you notice here, it just printed these things out. So what that means is that Python went through, it read all of this information in, it got to this for loop, it executed everything, and then it got to this statement and said, okay, we're no longer in the for loop, so I'm going to print this statement. Then it continues and it says, okay, I'm going to go ahead and do everything inside this for loop. And then once I finish, I'm going to come out here and I'm going to print this statement. So now I want to ask, if I hit tab and I put this here, what do you think is going to happen? And if you don't know, that's a-okay. Do you think that it will print it once?
I think it'll either print it like 0 times, or since there are 10 files that it's going through, it might print it 10 times. One of the two. Let's go with the extremes.
I like that. All right, so the second one is exactly right. It's going to print this statement, we are no longer in the first for loop, as many times as there are file names. So if there's 55 files in file name list, then this is going to print 55 times. So if I hit enter, bam, it printed it 10 times. But it only printed this one once. This print statement is inside the for loop because it's tabbed or indented. This print statement is outside of the for loop because it is not indented. Even though they're really close, they're in the same position that they are compared to the for loop, they do two totally different things. All right, so I think that covers, and again, I want to iterate. If you can print something, then chances are you can do some math with it as well, especially if it's a number. And those are kind of like hints. All right, so I fixed all of my stuff. Let me go ahead and uncomment this. So are there any questions about what we've talked about so far? Okay. I've talked about for loops and I've talked about the other basic stuff. Real quick, all these for loops are doing in a general sense is they are opening each file and storing the data into their respective lists. So for every time it goes through a for loop, it's going to add another data point. So when I execute this cell, there should be, 10 of these or 10 things in this list and 10 things in this list. So now remember in the back of your mind, or keep this in the back of your mind, that we are dealing with images, and images are two-dimensional. So there's a length and a width. So there are 510 pixels in our or 510 columns in our data and 725 rows. And that's what makes up the pixel. So if we continue, like I said before, it's always good to do a sanity check. Sanity checks come in many forms, but this particular one is to plot the image. And it's just to make sure that you've loaded in a picture and not anything else. So when I execute this cell, I should get something that looks pretty nice. You'll notice that this code is a little different from what you have, and it is a-okay for you to copy what you see here. The only thing I would say about this is don't let my Vmax dictate your Vmax. I chose this because if I choose the true Vmax, or actually if I just delete this, this time around it actually produced a fairly decent color bar. The first time I did it, it gave me everything as black, and that didn't make sense. But you want it to be different from black. And to do that, you might have to change this Vmax to, something else. And so plotting, well, that's again, and something else that could be a whole nother video. Practically everything that I've talked about could be a whole video in its own right. But again, this is just a sanity check. Most of the time you can just go and Google, how do I plot images in Python? And 99% of the people do this, and they copy and paste this into their code, and they just change these parameters to whatever they need them to be. So what that means is that I could take this and I could copy and paste it into another cell where I have to maybe open up some other image. And, you'd have to change this variable. You might have to change, what's inside that variable, but essentially everything here would stay the same. You just have to put in what data you want to plot right here. So if I wanted to, I could take this, I don't have anything extra on here that I could actually print. So we'll leave that be. But I encourage you to try to find other things to show. In fact, later on in this, you have to show yourself the data that you did take. All right, so are there any questions so far?
I don't think so.
Okay. So the next part that we will talk about is the first portion of the data analysis for the CCD saturation experiment. In this experiment, this was the data that we collected in lab 2. We were trying to find out exactly how much exposure time we would need, starting with roughly 30,000 or with 15,000 dish counts, how much exposure time we would need to increase to be able to saturate the chip at 65,535 counts. So what you do in here is there's some variables that you can use to do some mathematical manipulations on your image data to consolidate it. Let's take this for instance. This first variable is mean pixels. And what this does is it takes all of the image data that's inside of this list and it finds the average. It combines it all and then divides out, or it takes the sum total of all of them and then divides it by the total number of images that you have. And then it gives you what we are going to eventually call a master image. And you've noticed in class, we are constantly taking multiples of our pictures. And it's because the more counts that we have to do math with, the better. And so this takes care of consolidating all of those pictures into one. All right. All right, so there's some extra code in here that, like this, for instance, is not necessary at this point. You will need this later when we get to the quantum efficiency portion, but there you go. The next portion of code that you're going to see on yours has something to do with a fit on the line. This is nothing that you have to worry about changing or anything like that. If you want to, you can just look at this, and you can look at this through video, and you can just completely copy what you see here, replacing only your file names here. I mean, everything should definitely work. So when I run this code, what's going to happen is it's going to take all of the image data that I've just put in for my CCD saturation, and it's going to plot each of my data points with the total number of counts per frame or exposure time. And so if we take a look here with this data that I have or have been given, we see that we have this blue line, that's the fit. This blue line pertains to this equation. And there's some questions in the lab that ask you about these different things, and you have to think about it and try to maybe figure out, what's going on exactly. So you see here that there are 9 data points in total. That's because I have 9 files for my CCD saturation experiment. And we can see clearly that there's a straight line of linear response time to photons in our CCD chip, and then we hit a point where it goes flat. So now the blue line ideally should start with this point, end at this point, and you should see that this point is, slightly to the right of it. But given that I personally did not program the fit. I just used it from somebody else who has prepackaged this data together, or not this data, but these particular commands together. I have to make do with what they give us. So if you're following along in this video, or currently, you should have a pretty nice graph. That is if your code looks exactly like this. And you are free to pause this whenever you need to, go back and copy exactly what you see. And I try to leave the things on the screen long enough so that way you have a point to pause it where it's not moving. So are there any questions about the CCD saturation experimental part or the data analysis part? Okay. Now we get to the part that's kind of y'all get to do it. So if we read here, it says in the next few cells, we're going to learn how to find the local quantum efficiency for the columns and rows of our CCD chip. Let's do a sanity check and display averaged flat imp data and confirm that our data has loaded and successfully averaged together all the files in your given directory. You may use any code from in this notebook or put in your own. This is something that you are completely allowed to Google. Keep track of your major mistakes and positives. So how could I display averaged flat imp data? Well, first I got to make it, right? So I'm going to take that and I can copy it and I can paste it and I can make it a variable. I can also look at this and judge by the name of it that I'm going to need to average something or my stuff together. So do we have something like that in this notebook? Is there some command that happened earlier that we can use to maybe help us out? I got a nope. Oh, that was from a while ago. Is there anything in this cell that could help us?
Could you print it?
You are going to need to print it, that's for sure. But what we mainly need is we're going to need this, but we're going to need to change it. So when I say that you can go back and use any code that's in here, it's a pretty vague blanketed statement. You can literally pick up any piece of code and just copy and paste it. So what I did is I took this np.mean and I highlighted the whole thing and I copied it. And so what I'm going to do is I'm going to come down here and I'm going to paste it. But we're not ready to hit go because this image data is for the CCD saturation experiment. So we're going to need the other CCD data, which is what? Which variable is that?
I wrote down that there's the image data flat CCD sat and image data flat imp.
Imp is the one that we need here because these are the flats that we took for calibration of image processing.
Okay.
And so what this is going to do is this is going to store in this variable the average of this data. And it's the average of the data from our calibration experiment. So
Okay.
just to make sure, let's run it and see that we're doing pretty good. And as we said earlier, or as I've said earlier, it's always good to do sanity checks. So Rebecca, you mentioned earlier about printing. So we're going to print it, or sorry, we don't need that. And see what it says. Okay. The fact that it printed something with no errors is great. We're not really too concerned about the numbers inside yet, but the fact that it printed something with no errors is phenomenal. We're already on the right path. So these numbers here, each row of them pertains to a row of pixels within this averaged file or this averaged variable. And so now what I want to do is I want to show this variable or this image. So how could I do that? Is there code in this notebook that will help me do that? Would it be this? It would not be this. It would not be this because this is plotting. This is not showing an image. This is just going to plot some data. We just want it to show us an image. And so if I continue up, I can use this. And so what I can do is I can literally go here. I can copy this. I can go back down to where we were working. I can paste this in. And is this going to work?
I doubt it because it's not the same variable, is it?
I think it actually it might be. It looks like it is.
Hmm. Okay.
Let's see what happens. Yeah, printed out quite well.
Javier put a question in the chat.
I have a question. Why is that block of code to print the graph for the CCD saturation that you have different from the one that is? Okay, so the reason why this is different is because I felt like it would be bad if I uploaded this and cause more confusion if I uploaded this, because then people would be working out of two different notebooks. And I figured that the best way that I could remedy that confusion is by just making this video. And in making this video, everybody can look at this code and see the difference between what's on the screen and what they have and make those changes. If I put up two notebooks, there's a chance, or if I put up the second notebook, there's a chance that there's students who won't go back and check and they'll be using their old notebook. And then, it causes a lot of clerical and bureaucratic things that I don't want to deal with that I can just nip in the bud here. So that's the long answer. The short answer is mine looks different because this works across the board. The only thing that you should have to do is change your file path to whatever it is, wherever your image data is. The way that I had written it previously, it does the same thing that this code does, but it doesn't do it as efficiently. And as we saw from all the errors that we were having, That's not very good. So to answer your question, because it works for everybody now. So like I was saying in the video, it is, I can do that. I'll just do that. And if people decide to use the old code without looking on this new code, then shame on them. They deserve to struggle. So, yeah, I can do that. I will upload this notebook as well. All right, so moving back or getting back on track, we have done our sanity check for ourselves now, and you're welcome. What we're going to do next is we're going to move on to the actual portion where you're doing stuff for the experiment. So in the text, it tells you roughly what you're going to do. And what we're going to do is we're going to go back to this link and we're going to find all the code that we need to generate a histogram and to calculate maximum, minimum, and the numerical mean. So that way we can get a visual representation of our good quality pixels and some analytic data about our pixels. So the first thing that it says is we want to generate a histogram. We go to this link, you'll notice that there's a lot of familiar things in here. And just like I said earlier, most of coding is copy and pasting. And that's exactly what I did. When I found this tutorial, I just copied and pasted in what I needed as I needed it. And what's the chances that I would click that? So if you were to go through this and cross-reference it with your notebook, it might actually teach you a lot of stuff. And maybe, that's what you need if you're not a very experienced coder, is to sit down with this, sit down next to your code, and read this. So when you read through this, you're going to see all the familiar things and code names that I've used. And then you're going to see, hey, histogram. I didn't put that in there. But that doesn't mean you can't come back here and copy and paste what you need. If you're reading through the tutorial, some of these cells, we don't need it. But what we do need is this. In fact, it would probably be good to grab this as well. So we'll grab this and we'll paste it in here. We'll go back to that web page. We'll copy and paste this into here. And then we don't have image data. Image data isn't what we're using. We're using this. And you see that I've changed the first option in each of these. So if I hit this, we should get a histogram. Takes it a minute, as you can see. But now look, we have this nice little histogram. There are some other attributes that you can add into this portion, which attributes, that's a whole nother video that I could make. This is an attribute, and this attribute tells the history function what data we're plotting. This attribute of the histogram function tells us how we want to bin our data. And in this case, we're doing an auto bin and we're letting it take care of it for us. I could tack on another attribute by putting a comma And I don't know what it is exactly, and we could look it up, but we could do something with range or x x-axis. We could look that stuff up. Let's try that first. So when you do this and you Google things like this and you find what you're looking for, you get this mumbo jumbo. If you take your time and like pick through this, you'll really see what's going on here. Range, that's what we want. That's the attribute that we want. So let's take this and let's put 0 to 15,000. Positional. Oh, it didn't like that I skipped. Okay. All right, so look, here's a great opportunity for learning. I've never used this range function before, so I don't know what I'm doing. I've just hit an error that says that I have a positional argument which follows keyword argument. That means that it doesn't like that I've put another comma in here. So how can I fix this? Well, if I go here, that particular thing does not work, but it says tuple or none default. So look, the lower and upper range of the bins. Lower and upper outliers are ignored. If not, provided range is V or X min, X max. So what we need are some parentheses around our range. That should work. Okay. So I had no idea what this does. I mean, I had a guess, I had an inkling, and I figured it out. And all I did was I just looked up how to use this and I read the text. And I saw that, okay, well, the difference between my code and this code is that there's a parenthesis here and there's a parenthesis there. Yeah, of course, the stuff in between is different, but the general organization is the same. It's a parenthesis, lower bound, comma, higher bound, end parenthesis. Does that make sense? All right. So when I go here and I look at my histogram, my newly generated histogram, it's kind of hard for me to see much action at all, but there's this huge blue spike. That's pretty cool. Does anybody want to tell me what the x-axis of this histogram is? You can leave it in the chat if you'd like. Okay, so the x-axis is, how do I explain this? This is the number of pixels that have counted, or let's just say it's the pixel bins is what they are, easiest. There are, if we were to zoom in more, let's see what happens. If I take this and I make my range from 10,000 to 13,000. Let's see what happens. All right, so I have a nice little histogram here now. All right. Okay, so the x-axis are the bins for our range of photons or our counts of photons. So what this means is that the number of pixels, or there were 11,500 pixels that picked up approximately 7,000. I'm sorry, I said that backwards. There are 7,000 pixels that picked up 11,500 hits. I'm going to say that again. There's approximately 7,000 pixels that picked up approximately 11,500 counts. Okay. So let me, there's this point right here. We'll try to do this. Actually, let's not. That's not a good one. This would be good. All right, so how many pixels have approximately 2,000 counts? Did I say that backwards? How many pixels have, did I say how many pixels have 2,000 counts?
I don't know, but I think Javier put a guess in the comments.
All right, so I see. All right, so yes, there would be 2,000 pixels that picked up 11,300 counts. Yes. So how many pixels would pick up 11,600 counts? You want to give it a try, Rebecca?
Um,
How many pixels have counted approximately 11,600 counts?
on my screen, it looks like it would be somewhere between 3,000 and 4,000.
I'd agree with that. I just want to make sure that you know how to read the graph properly. Yes, I agree with that. All right, so let me go ahead and fix the range, and then we're going to conclude the video by going over how we could, or the strategies that we could use to calculate what I'm asking for here. All right. So the final portion of this, it wants you to calculate the mean, max, and minimum counts for your averaged image. And then what you're going to do is you're going to compare these maximum and these minimum to your average. What that's going to tell you is compared to your average pixel, how many good pixels you have that are more sensitive than the average. And then it's going to tell you how many pixels you have that are less sensitive than the average. And that's going to give you your relative quantum efficiency. And so, if we go back to the link that I gave you guys and we continue further down, on our journey here, and we're reading all this stuff and learning how to plot images and show these things. And this particular thing tells you how to stack images. We're not too worried about that. The next thing that we're going to need, actually, I think we passed it already. It's something that we had earlier. Here we go. We're going to need this stuff because it does exactly what I need you guys to do. So if I copy this and then I go back to my code and I paste this in, I can, change the variable because we're not working with image data. We're working with averaged flat imp data. I can just go ahead and paste those things in. Okay, and so then when I execute this, it's now going to print the minimum value of counts, the maximum value of counts, and the mean value of counts. All right, this is good. So now, how can I compare these things? How should I compare these things? What math should I do to compare these? Okay, so what we want to do is we want to calculate like a ratio of sorts. So then what I mean is I want to see like the max compared to the min. So what we'll do is we can just write ourselves a print statement that says comparing max and min, we get, oh, I don't need these quotation marks. I can just use commas or yeah, apostrophe, sorry. Comparing max to average. Okay, so what I did here, or what I'm about to do here, is I am taking the maximum value and I'm dividing it by the mean value. And when I do that, what I'm going to see is that the pixels that are receiving the most photons are receiving them 2 times more efficiently than the average. Actually, we could probably say 2.1 times more efficient than the average. Okay. I want to use the same cell, same code. Let's compare the min to the average. Okay, same mathematical operation. All we did was change max to min. Okay, so now we've printed our min value, our max value, our mean value, and comparing it to comparing our max and min to the mean, we see that our minimum, our pixels that are counting the minimum number of photons are calculating them about 91% as efficiently as the average. It's about 90% of the average value is what our minimum photons are our pixels that are calculating the minimum number. That's that quality. Okay, let me make sure I answered all my own questions. Yes. So I want to ask you guys, are there any questions?
I don't think I have any. It's just a lot to process.
It is a lot to process. I highly encourage all of you, if you're having some issues, to get a hold of me And obviously, the more people that get a hold of me, the better, because then if everybody's having an issue, I can extend the due date a little bit. I will go ahead and stop recording. If you have any questions, you are free to email me. Those of you watching the video, good luck to you.